Hi guys, welcome to, this is actually going to just be a short example for people who want to learn how to write a basic program in Atari Basic. You see before you here, I've had this projected on my monitor, and I'm actually right here. I just using my digital camera to display the output this way. I couldn't figure out any other way to do it since there's no sound audio connectors with the Atari that can actually communicate to the PC computer. So I kind of figured that this would be the next best step. So what you're looking at here, though, is a simple program. It's just an animation kind of thing. It'll show you how to control the joystick. And for those who want to know, this is actually, I don't have much room to move around here, so excuse me. This is, you can see it, this is the Atari Joystick right here. Turn on the light and you can actually see it. This is, that's not even much better. This is an Atari Joystick. It has an up, down, it has a left, a right, and it has a fire button here on the side that allows you to control. Just like, this is just more like one of the newer fashion ones. But this is what a lot of people use for the Atari 2600 computer when they were trying to, people were just playing games. If you grew up on the Atari 2600, I certainly did use this a lot when playing games. So this can also be used to control basic programs and manipulate the joystick to use. And that's what I'm going to demonstrate with this program right here. I'm just going to kind of run it just to kind of show you what this is all about. So I'm over here typing. You just execute the run command that will run the basic program. And this looks really horrible. I'm going to turn off my light here again. Kind of get rid of some of that background illumination. You're looking at, it's probably not a really good display, but you're looking at Graphics 3 here. And you see up in the left-hand corner, you see this little thing right here. This is my cursor, and I'm basically able to move it around. It looks kind of funny when I move it here and record it, but it's not actually dragging 3 boxes, it's actually just dragging one here. So I think it's because of the way the display is connected up. It's kind of reading it real time. But anyways, you'll be moving this little cursor around on the screen here. And this is a simple program where I got like a little maze here in the middle. And you know what? I need to correct something here. I think I changed this earlier. I turned something off here for a second. Let me just diagnose this for 1 minute. Let's see, x equals 0. I think it's this line. The only one I changed recently was this one. Oops, my one. I think it's got to be that one. Let's see. There it goes. Okay, so it wasn't supposed to go through the screen earlier. You saw it go right through the maze there. So now when you hit the walls, it's going to stop at the walls basically right there. So in the center here, you can see, you probably don't see it very good, but there's actually a green square here next to my orange square, and that's just a little program I designed, and this is horrible. You can't read the display at the bottom. Let me turn this light on, see if that helps any. I don't think I'm going to do much more of this. I'm going to try to find a better way. But at the bottom here it says, "Nice job, you found the cheese." So basically it's saying in this little game of Mousetrap, you navigated a simple screen, went inside the cage, and you found the cheese. So, and I'll show you the line that actually did that. You saw it here earlier. This is getting really bad. Okay, now I see why it didn't come out. Right here, in this line right here, you see where it says "Nice job, you found the cheese." It's just printing that in inverse, which allows it to change the reverse character of the printout. So let me run this again. Okay, so I'm going to see if it was going to make the display. Yeah, you still can't see it at the bottom. It prints it right there at the bottom. It's just giving too much background illumination or something. But I don't know. I played with everything trying to get this to display correctly, and this is really going to bug me. But anyway, for those who are curious the way this kind of works, man, it's hard to work over here and there. If you look here at the top line here where it says Graphics 3, that's just setting the mode that we were in earlier. And you see the x equals 1, y equals 1, z equals 1. The x equals 1 is just telling the x position of where your player is going to start. X is a common thing for horizontal and horizontal movement. Basically allows you to move forward and backward. And the Y is vertical, so allows you to move up and down, and C is just the color I indicated down here in the next line for the little dot you saw on the screen earlier. So basically this is going to plot it at wherever X and Y is, so it's plotted at 1, 1 basically. And the next line here, as you see it underneath here, this is just drawing the cage you saw in the middle of the screen earlier. This right here is just actually drawing a black line on the left side of the box, so it has an opening, because I originally drew an entire circle, which is easier to do it that way. The color 2, this indicates the little dot you saw inside the cage. That's the cheese basically, and that's just where I positioned it. J equals peak 632. For those who want to know, I don't know if you're going to see this or not, this book is called Mapping the Atari, and you can find all the address codes directly in this book, which will show you step by step what each poke, they're called actually poke and memory locations, is actually doing. And this one I put J equals peak 632. So if I go to page, and I know you're not going to see this, but if you go to page 627 in here, there's a place here that talks about the joystick, and this is horrible. Let me see if I get this in a closer. You can actually get this online and probably print out the actual PDF, but right there, man, this is the last time I want to do this. You see what it says 632 there? If I hold it clear enough, that's the joystick. So that's just showing the positions of the joystick, which you saw me earlier move it. 14, 13 is up and down, 11 and 7 is left and right. So that's the easiest way to indicate, and those are the binary representations you see over there to the right of it. Okay, so this is a great book. I got it on eBay for a pretty good discounted price, so it really helps you when you're building applications like this and you want to be able to design your own games or whatever you're interested in, whether you're interested in card games or just counting, which is probably not common these days. Nobody really uses a basic computer. I mean, we're all using PCs and Macs and stuff like that now. Keep in mind, this computer came out back in, I believe it was 1981, if I'm not mistaken, when Atari released the first, it was an Atari 400 computer. The one I'm using here, which I can't pull it around here. I could probably swing the camera around here a little bit, maybe. You see it down there in the corner there? I should have just turned the monitor, but it's right there. Right here. This is the Atari 800 XL. So that's the one I'm using, and this is just a disk drive right next to it. So that'll actually kind of give you an introduction to those who want to know what the Atari computer is. I'm going to really hate doing this. I'm like using one of these pivoting cameras and trying to get this thing centered, and I'm not happy with the vertical alignment and the way it's showing up on the screen here. So it's kind of looking at it lopsided there, so kind of play it with there a little bit and move it around. So excuse me, I'm kind of a perfectionist on how things should look. I just think it should look better when you're explaining stuff. Anyways, this is the program in the application. I'll get right back to the line here in 1 second. Here we go. That's about to try to get them to get it. Play with it a little bit. Okay, that's not too bad. Okay, so right where we left off here, that draws the cage and the dot, and then we start with the joystick, as I was indicating earlier. 632 is obviously the start of the joystick, found in what was called a memory location in those days in Atari. And then what it's doing here is it's taking the color C, which was 1 earlier, so now the color is going to be 1. If you saw me moving that dot around earlier on the screen, that was orange, so 1 is orange. And then plot X, Y, it just takes the position that you set. I set it at position 1 X and position 1 at Y. So this is basically a mathematical coordinate of where you're putting it at. Okay, and then down here underneath it, this is I'll explain this later, but right now what this is doing is saying x1 equals x, y1 equals y. That's keeping track of your x position, which we're going to be using later. So once we move it, we'll remember where it was previously. Okay, so these lines, if j equals 7, keep in mind these are variables, by the way. So this variable is just setting memory in location into peak 632. And to kind of explain this, to go to the next step here, I want people to really understand. Give me 1 second here. So what I'm doing right now here with this little insertion into the program is you're gonna see the screen in a minute fill with a bunch of numbers, and this is gonna show the joystick positions that were being demonstrated here earlier. So right now you see it at 15. So if I move the joystick up like this, You see it changed to 14. If I move it down, now it's 13. If I move it left, it's 11. If I move it right, it's 6. I had to look at it to barely see that myself. So these are controlling, and 15 is in the center. Basically, you're not doing any movement. The fire button is not responding to this program because I haven't programmed it in. But anyways, let's get back to that and I'll show you that. You can use L period, by the way, just to list it as a shortcut way. Okay, so back where we were. J equals 7. Remember when we used 7 earlier, excuse me, 7 indicated to the right. So this is basically moving the X position by 1 point each time. So X equals X plus 1 is adding X to 1 to plus 1. So if X was originally, what we have it as 0, I think it was 0 or 1, it would now become 2. And if you move the joystick again right, it would become 3, 4, 5, and that's what's indicating the thing moving across the screen over to the right. And this right here, if X is greater than 39, then X equals 39, is what I like to call a barrier. So it's basically trapping the dot on the screen so it doesn't go beyond its coordinates. So if it's at 39 position, then it's going to stay at 39 and not go anywhere else. This one right here is actually moving it to the left. J equals 11. If you remember earlier when I moved the joystick, that was moving it to the left. So now it's going to say X equals X minus 1. So this is doing the reverse. What this is actually doing is just moving it backwards. So let's say if X was already at 10 position, you had moved it in the screen somewhere here, and you started moving backward, then X would be 9, 8, 7, 6, and so on. And this keeps track of it moving backward to the left, and it traps it after you get to 0. So before you get to 0, which is what this means, X is less than 0, it's going to trap it as 0, and it's not going to go anywhere else. But I'm going to get tired doing this, but here we go. Okay, so the next one is saying if J equals 14, then Y equals Y minus 1. And if anybody can guess, this is just basically going to control as it goes up the screen. So remember the X comma Y, this is the vertical, the horizontal and the vertical. So if Y is less than Y minus 1, it'll keep subtracting from Y. So as an example, if Y was at 15 and you move the joystick up, Y would suddenly be at 14, 13, 12, 11, and it would just keep going back until it hits a trap here saying if Y is less than 0, then keep Y at 0 so it doesn't go off the screen and give an error message. The next one is actually controlling the down movement of the joystick, and you can guess this is just doing the same thing as the reverse of the X we saw earlier up here. It's just moving the Y down the screen, basically moving your little dot down the screen, and this is saying if Y is greater than 19, then Y equals 19. So basically it's keeping track, what it's doing is it's keeping track of the vertical location of the little dot moving on the screen there, the little plot we have basically, and keeping it inside so it doesn't go beyond those barriers. Okay, so this one is, if you remember earlier, peak 632 equals 15. Remember earlier when I was showing you that little example where I added the insertion of the print peak right here? Right here where it says print peak 632. So what this is doing is it's saying is if the joystick is suddenly idle, in other words, are you not moving it? Is it at 15? Because that's the center idle location. If it is, then we want to erase the dot on the screen so we don't leave any excess, basically any repeating drawing on the screen, so it doesn't look like it's just drawing the line, but it's actually moving it like in an animated motion. Okay, so this is just basically going to erase it. This one is saying if you've already moved the joystick, then also erase it. This is to make sure that there's no extra excess. I've done this before because sometimes it just leaves little dots on the screen based on where your X position was moving. And if you look here where it says plot X1 comma Y1, remember earlier back here, if you look back here where I had X1 equals X and Y1 equals Y, it's keeping track of where X was originally. Remember when I told you this? And if I go back down here, the end, so what it's doing is it's going to erase the position before I had moved anything. It's going to erase where it previously was, and that's what it does. It keeps track of where it was originally and erases it. It's kind of a trick to get the animation to look right. This one here says locate X comma Y comma color keep in mind the X and Y again is your plot for your little dot. The color is just a variable. You can call it anything. I just called mine color. If COL equals 3, then we're going to do something. What this is saying right now is the color that you're touching blue. 3 is an indicator for blue because this position right here is checking for a color of that little dot you saw moving on the screen earlier. So if the color is blue, then X equals X1, Y equals Y1. So what that's doing is it's actually keeping track. If you ran into that little circle earlier, then you want to get trapped. And let me just run it one moment to show you. Real time. Oops, I forgot my little extra in here. So, if you're moving the mouse and you suddenly hit this wall here, I hope you can see it, it's blue. It's not going to go anywhere, right? It's not going to let you go outside this little box. Because originally you saw me, which I'm probably glad I did it, you saw when I didn't do that, it kind of erased what was in the center when you ran over it. So, back here again. So basically, what that's doing here is it's saying, okay, if you've touched that box, that blue box, then we're going to keep track of what X was, I'm sorry, we're going to keep track of X as it is right now to what it previously was. So before you previously moved the mouse into the box, what was the position, and keep that position. That will allow you to trap whenever it hits an object instead of passing through it. So it's a way of keeping track of where your X and your Y previously were at. This next line, it says, if col equals 2, keep in mind this is still our locator, then print CHR strings 253. So this is saying color equals 2, and 2 is actually the green color you saw in the center of the screen earlier when I ran into it, but you couldn't see the message. But I ran into it and stopped the program. So if it equals 2, then print CHR's 253. This is a character set that's built into the Atari computer, home computers in those days, and it makes a little ringer sound. So if you hear this sound, that's indicating the ringer. And what this next thing does, it's kind of a concatenator. It's got a little semicolon here, and it shows a little up arrow like that, a curved arrow. That curved arrow means erase the screen, basically. And then once it hits that, again, once you're hitting that little green dot in the center, you're going to not only ring the bell, but you're going to put a little message, and I just wrote, nice job, you found the cheese. So that basically means you ran into it, your goal, which was to get the cheese. And this go 230 down here will loop all the way back up here to 632, so it's basically going in a cycled loop to make sure that the joystick is constantly being updated. If you don't use the go 230, the program will automatically end, and you won't be able to do anything with it, because it automatically, once it gets to no lines at the end and you have no go-tos inside of Atari, it just ends. So that's kind of the gist of this one. Let's see here. Yeah, just ran it one more time here, and watch you when I go back here in center of the screen. This is what I mean by the axis. You know, see that put that little dot on the screen. It's still something little bugs I have to fix in there. It's still keeping track of where X previously was, and sometimes it's throwing it out. I think that's probably because there's more than just an up and a down position. I remember this before. There's also a vertical position where you can kind of move it up at an angle like that, and you can also move it up that way and down at an angle and down at another, like a 90-degree angle there. So, and when you're doing that, it's not doing anything, so it's still throwing the dot on the screen. It's just, I would just have to set controls to keep track of where the joystick is in those positions, which can also be done with that J equals P thing. So anyways, in back here in the center, so we hit the center, listen, rang the bell, and down here at the message, you can't see it, but it's printing that little message in a little box that the Atari, it's what's actually called a display box that the Atari puts on the screen for graphics mode 3. So, and these videos aren't very successful. I probably won't be doing many more, but it looks like these screens are looking really good, but the other screen I'm still not very happy with. So that's kind of it for right now. If you have any questions, just go ahead and respond to the comments, and subscribe if you're interested. I might be putting more Atari videos up there. I've mentioned this in one of my other videos, but I've actually bought a computer, Atari computer, not this one, but I bought an Atari computer back in 1986, and I've been playing with them probably since 1993 until they started coming up with like the Commodore 64. So I've got a lot of experience in this, and I've kept a lot of my books and stuff like that. So I'm pretty skilled on this, and I think I could really help people who really might be using like emulators on the internet for the Atari. And I know that there's some people in the United Kingdom that even have some computer clubs and stuff like that. If you're interested and you want to see these videos thrive and continue to go somewhere, just let me know, and subscribe also, and maybe I'll just, like I said, maybe I'll expand that a little bit. But I also noticed, as another extra note, that the machine language ones are getting a lot more hits than the ones for BASIC are. I think that people are more curious about how the machine language coordinates work with the Atari computer, which is actually known as the 6502 processor, versus BASIC itself, which just runs its compiled program line by line. So I think I'll probably go into more depth explanation on that later. I do own a Mac 65 cartridge, which allows me to write some pretty sophisticated machine language programs. If you're curious also, I got that on eBay, but that was a very hard find. So anyways, you guys have a great day. Thank you for watching. I didn't even stop the thing here. Give me 1 second here. Don't you love that? It's like I'm trying to figure this camera out still. I think it's right here. Let's see, full screen. So right click. Reduce noise.